himself since he has. Okay, yes, I'll be giving a presentation on analysis of type 1 diabetes by machine learning techniques. This was my MSc project under the supervisors above, mentioned there. Two of those, the first two are my core supervisors. They are both physicists at the School of Physics at the University of the Witwatersrand. And then the last two, Professor Justine Davis and Dr. Alicia Wade, the clinician specialists who specialize in type 1 diabetes. So you might be asking your course, your main supervisors are from physics. How did you build up with the diabetes specialists now? My main supervisors mainly work with CERN, Atlas Data, at the Large Hadron Collider. So they basically do analysis there of the data sets that they have there of the collisions that happen in Atlas and yes. So now, coming from a maths and physics background, I was a bit maybe tired of the abstract and dealing with numbers and everything. I was just like, okay, I'd like to do something more applicable, something that I can apply in real life. So I was asking my supervisor, can't I use these techniques that all of you guys are using there maybe into something more applicable? Then he's like, okay, then you have to think of a data set, which was also a trick now. So I thought, what can I work on? What can I work with? And then I remembered my favorite person, who's my grandmother. She has diabetes. She's been living with it for more than 40 years now. So I was like, okay, but where am I going to get the data set? That's when the two core supervisors came in. And fortunate enough, one of them is also a doctor to my supervisor, so it wasn't really, really hard getting the data set, as most people face. So what's special about our data set is that it's verbal autopsy data. In most developing countries, we find that it's very, 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 very near impossible to, especially developing countries, the rural parts of the developing areas, it's very, very hard for us to actually know what people died of because there are no very, very good health registration systems, either because they are not there or there are just not enough patients getting into the health facilities. So now, also our stats show that over 60 million of the annual global deaths that happen every year, most of them, which is like a great majority of them, go unregistered. So that's why I was very interested in this data set and said, okay. So the image here shows an example of how we collect this verbal autopsy. The World Health Organization just basically sets out the standard questions. This is basically a questionnaire, just a page of it. And then what happened is that a data collector visits a family of a deceased individual, and then they ask certain questions about the disease. The responses will just be yes, no, I don't know. But with great advances, the questionnaires have shifted somehow, and they're also able to mention, in text, they can actually tell a story of what actually led to the disease, and not just respond with yes, no, I don't know. So we were interested in type 1 diabetes of this data set. Type 1 diabetes has been shown to be a global burden, with the stats from 2013 alone at 320 million. And the International Diabetes Federation has estimated that the numbers are expected to increase rapidly to 592 million by 2020, which is next year. So of great interest is that most people who actually have diabetes don't know that they have diabetes. And they end up progressing to very, very critical stages where now they're not even able to be given proper treatment of this disease. So we decided, okay, let's employ machine learning techniques, particularly neural networks and random forests, because they're the ones that, they got the most, I don't know, they're the most reputable, I can say. But now we found along the way that, okay, certain data sets are good for certain things, for certain models, and certain models fit perfectly for certain data sets. So please don't get ahead of yourself, but I'll take you through everything that we went through. Machine learning techniques have proved to be more accurate over time, over their statistical model counterparts. This is because of most techniques that they employ, which are streaming data over networks. You can process data in many batches. You can also, the computational speeds are very big also, due to the fact that we moved from central processing units to GPUs, the graphical processing units. So the data set. Dr. Alicia and Professor Justine, who I've mentioned before, who gave us access to the data set. One of them is currently based at Wits and works in close, she's found in the School of Public Health, and she works in close approximation with the Agincourt group, which is the HDDS, and they provided us with a data set from 1992 to 2000, which was collected on an annual basis. They also now, oh, I forgot to mention, they actually conducted a, they wanted to have a weighted score that would help them in using this data sets, the verbal autopsy data sets, to actually help them in making estimations of the correct values of numbers that people actually get from this data sets of people who actually die of the disease and people who don't die of the disease. So they took this data set from Agincourt, and for the validation of their model that they built, they used another data set from also another HDDS, which is in Malawi, Koranga district. This was what the Agincourt dataset looks like. So now, looking at our features, we see that a verbal autopsy is not just specific to one disease. You basically collect for all diseases. Could be diabetes, we have also tuberculosis, we have HIV. So now if you're interested in a specific disease, which we were in our case, would then have to do a lot of data pre-processing, which was done with their help. They helped us with the use of a dictionary to actually identify symptoms that are found to have the most dominance in predicting or classifying type 1 diabetes. I've taken a screenshot here. It shows just two features, which is tuber and then the diabetes. We also have at the left end there what each symptom means. So after a lot of pre-processing from actually, we identified also, I think you saw we have the age feature here. So due to the fact that it's very, very hard to find the difference between, it's very hard to identify the differences between type 1 and type 2 diabetes. We tried to, one of the most, I think, important pre-processing steps that we did was to actually limit the age range, which for people under the ages of 1 or infants, they were found to, the disease is rare in them, and then for people above the age of 49, the difference is even worse to identify between type 1 and type 2 diabetes. So after those types of pre-processing steps and actually going through the data dictionary to identify symptoms, we ended up with 10 main features, which were the following, which would help us now do a classification of which we would run our models on to find the best classification for the disease. Now, there were about 15,000 of these data sets, and then 8,699 features were the ones that had symptoms which could lead to diabetes, and then 79 of this were determined to be the type 1 diabetes patients who died of the disease, and then the other ones were shown to not have the disease. Of the 79, 37 were shown to have been diagnosed in their final illness, which is also a red flag because it means these people could have easily gotten the treatment they deserved, or they could have easily treated the disease before it actually took their lives. Now, before we created the random forest model, we created a neural network model which we ran and which we fed our features on, and then since I think you see from the stats here that we only had 79 positive cases out of the 8,700. So our data set was not like evenly distributed, so we went into the evaluation of which performance metrics could help us in knowing which, how perfect or how good our model was at doing the prediction or the classifications. So for the neural network, we ended up, we were able to like select, do a feature importance, and then we were able to check which features are most dominant in actually doing the prediction. And then for the random forest also, we were able to run like a parameter test. It also showed us which parameters were actually optimum for the prediction of the disease. We went, since we couldn't use the accuracy metric because of the class imbalance, we used confusion matrices which were able to show us which data sets, which classes were correctly classified and which ones were not. We, for comparison's sake, the metric that they used, which will follow from the question that I asked in one of the summer school lessons, was why are rock curves the most dominant in medical analysis of diseases? And the best result that we got is that whenever we do medical analysis, we are interested in actually how many positives or how many times our model is able to predict the positive cases. So in this case, the two rock curves also show how the models generalized over different sets of positive and negative positive cases. And then we found that the random forest was fairly able to classify our data sets well as compared to the neural network, which also did fairly well. And then we were also able to do performance metrics like precision and recall, which would tell us how often our models were able to identify the positive cases. And this is just a summary of all of the matrices that I've talked about. And we were particularly interested in the area under the rock curve, which is the one that basically gives us the overall summary of how our models performed. And we have the random forest still leading very far off from the neural network, which with at 83%, we really took that it was performing quite well. And now for the last step, which was to actually now with all those matrices and performances, now the actual question of now how many number of positive cases were we able to identify from this verbal autopsy data set. The study physician, who is the one who actually does the review of the data set before the study physician is like a physician who, when all the verbal autopsies are collected, they're taken to them, and then they actually go through, obviously they're specialists of the disease, so they know that, okay, if this certain patient had this, and this symptoms, then they actually died of the disease. So they are the ones that we were actually comparing our scores against. The weighted score that was found by our collaborators through their own methods, through their own models, showed that they had 75 positive cases, and then the random forest and the neural networks, which were the ones that we created, gave also their results, and then the random forest was still leading, but the neural network was not doing so well as compared to the weighted score. So we did reach to a conclusion that machine learning techniques can really help us in actually finding or reaching to a weighted score that would help us to, in the near future, or in cases where the study physician is not available, because most of them are busy treating patients anyway, to be analyzing verbal autopsy data, then we could be able to have this weighted score that would help us to apply it in any incident that we have to actually find the number of cases of patients who died of maybe in the next project. We'll deal with more than type 1 diabetes, but for now, this was all we had. And we did have a lot of challenges, which I think my time doesn't allow me to say, but most of them, yes, but yeah, I hope one of you guys will ask me what the challenges were, then I'll be able to.
So guys, right about so what we're going to do is have 2 questions that sort of pique you, just to ask, what was the paradigm of your work, what were your challenges? Briefly. Okay, there's the question here.
Okay, what's your challenge?
I'm so glad you asked that, because now I'll be able to finish off my presentation. One of the challenges was just mainly trying to reason with the clinician specialists that we're not trying to take over your job, or we're not trying to override your models. We're just trying to see if we can reach the certain accuracies that maybe we can match up against yours, which was also quite a challenge for me, because I would have loved to. I mean, South Africa is way developed than my home country. I would have loved also to conduct a similar research with data set from my country, but the challenge is that it's not easy to get health data. Systems are threatened by people asking for data. So this was also one of them. Yeah.
Thank you for your interesting presentation, but I have one question or question. So, how did you prioritize those metrics? I think you have specified 10 metrics, and from those metrics, how did you prioritize, or how did you select those metrics from those? Thank you.
So how did you select the 10? Then let's get this the last one, so you can answer them together.
Thank you very much for your talk. Coming from a medical background, I know that it can be challenging to work with us. I was wondering whether they gave you whether they gave you anything to kind of assist you in your data analysis as well, or whether it was literally their work and then your work, and that's how you then came to compare your scores with working.
For one, I'll start with his and then get to yours, because her question comes way before in my presentation. You were saying, how did I get to the 5 features, or how did I increase the Oh, I'm so sorry. how was I able to get help in the features that we? Of course, I didn't know that. For one, I didn't know that chronic cough is a symptom of diabetes. I didn't know that diarrhea could be a symptom of diabetes. So,
but did they give you any weight to these symptoms? Because some of them are very vague and they can just be, I guess, rather than like definitive markers of diabetes.
if I'm going to be comparing two models, then we have to be working with the same features somehow. These were the features that they got to say, now these are our features that we work on. So if I was going to compare my weighted score against theirs, then I would have to use the same sort of, yes. So I was guided in that way maybe, yes.
I think you shot two birds with one stone. Right? Am I correct? Yeah. Thank you. Any? Let's take our presenter. Yeah. So we're not copywriting enough. So what we're going to do is we're going to hold like.